Hi guys and welcome to another DevCast. Today, after quite a long pause, it will be talk about Machina. There's a reason why I returned to Machina for this weekend, and that's curves, because you probably saw one of my earlier videos about curves in Machina, and I was thinking about kind of decoupling the curves from Machina because we want to use it in our other projects and so on. And I did that, and once I was doing this, I went over the API that I did for the curves before, and so on. And I've added a lot of additional stuff like normal handling, like uniform distribution, and so on. And once doing that, I also wanted to showcase the curve on some kind of procedural generation of geometry, and I wanted to generate these like rails. It's a monorail, uh, and to do that I had to fix some other stuff in Machina because there was some explicit problems with extrusion in polygonal objects with a very specific triangle loop and so on. So I did that, and additionally I did some UI changes as well that will be ported to Dash, because as you know, I a lot of the times I do a new stuff in Machina and vice versa to just work on the node-based framework I have, and I port them and also test them in between. So let's go over the curves. We have this scene here, so let's just start with a curve. So this is probably very similar to what you already saw. It's basically a curve editor. Now it's directly once you go over the node. Uh, it is also code-wise it is decoupled. You can take this. It's a curve type, and it has its editor inside it, so you can basically take this into any project. But it is wrapped nicely into the Machina framework as well. So, and this is basically two types of curves. You can use a linear curve, and then there is a Bezier curve. To be more precise, it's a cubic Bezier curve. I didn't implement the quadratic Bezier curve because I don't think it's that useful. If you want that, or you can you can say why you think a quadratic Bezier curve is useful. Just let me know, and I may add it. And then there's the segments, because you then interpolate these curves in segments, and so on. And this is basically the points of the curve. So to uh, to go over the editing, it's pretty simple. It's you just select the point you want to edit, and then you using a control click you can either add if you click somewhere else like here, or you can remove points. Okay, so this is the curve node. It's also the curve type that I will be moving as needed to another project, and I maybe even release it as a separate repository. And now what I wanted to do with the curve was generate a railroad, basically a monorail on this terrain from our game. So let's just go over that just for fun. So I have this uh, terrain, so I bring it into the Machina graph just to have the geo for raycasting basically. And then there is a project node. You probably saw this project node in one of my demos from Machina. What it takes is takes basically any mesh. It doesn't matter if it's a triangulated mesh or it's just a set of points. Even the set of points is a mesh in, so even this curve is a mesh inside Machina, and it will project that points uh, on this mesh which is specified by the second input, and it will be projected using this direction. So we are basically projecting it down. We are using ray offset, so because this curve is really really very near the actual terrain, so I'm using a ray offset, so it will be brought a bit upper and then it will be projected down. And this final offset is, if I just enable the vertex here now, these are the vertices, the projected vertices of this curve. If I show you this curve without the projection, it's pretty flat. These are the interpolated vertices. And if I go to the project node, you can see that now they are projected onto the terrain. And this basically specifies additional offset after the projection. So you can move it a bit up or down, or it's using the direction. So now we have these projected vertices. So what we can do, and what I showed you, is a copy to points. Let me show you. We have this simple box here. It's it's just this very simple box with these parameters, which will be set under the monorail. And I set the material to that. It's some kind of like wood material, but it's not really wood. But it looks good. So now I take this box and these points, and I use copy to points. So I'm copying all this geometry. Let's hide the vertices. All this geometry on that terrain, basically with those points. So now if I just show it like this, we have this nice wood. As you can see, for example here, the distribution along the curve is not really uniform, or it's very uniform. If you are familiar with Bezier curves, they are not this uniform. This is because this is already using the uniform distribution, but we can work on that even more. So let me show you. So I have this type of curve which is Bezier, and then you can specify this type of distribution of the segments. And let me show you the standard linear, or I call it linear distribution. And as you can see now here, there is a lot of like small spaces, but near this point, and especially along this part of curve, because this control point is really close to this point, whereas this control point is not that close. So which means the linear distribution basically takes a value, because we have a normalized value. This is the start, which is 0, and this is the end of the curve, which is 1. And then goes using the polynomial equation, which is for the Bezier curve. Is actually a set of equations, because you have like multiple splines, because single Bezier segment is like 4 points, and then it's just the last of the 4 points, and 3 additional points is the next segment, and so on. So it just distributes this normalized value between the segments. And if, for example, you have a small segment and a large segment, it still means that the small segment takes the same amount. So for example, if you have 2 segments, each segment is from the normalized value, it's a half, so it's 0.5, and so on. And even on the distribution using the polynomial equation, you see that it's not really same within the single segment, how the value distributes across that. So I added the uniform distribution, which is way better, and we can even make it even more better. Just let me explain how uniform distribution works. It just basically pre-calculates the length, and then it like projects the uniform distribution normal to the standard distribution. So for example, so it just goes over the curve using the segments or a different value, which is here, and then just calculates the distance between all these pre-calculated points, and then this just is it's cached into the array of lengths basically, and then from this cache we can calculate how we can basically specify based on length, not on the normalized value of the equation. So then it's just projected. I don't not sure that if you uh, if I explain it simply enough, but basically we just pre-calculate all these lengths, and then these what I mentioned. For example, if this segment is small, if we just pre-calculate the real length, the difference between the points on the segmentized curve, the real length of the small segment will be small. It will not be half of the if we have two segments, it will not be half of the whole length basically, and then you can calculate the distribution more precisely and more uniformly. So this, however, the precision is as good as the precision used when you calculated or pre-calculated the lengths. So I am basically calculating length using 100 segments, whereas then I am distributing over 200 or 200, exactly 200 segments. So if I just go this, and let's just say I want to 1000 to calculate the length, now I can see that the precision of the uniform distribution is way better than using just 100 segments. I can if I go by 10, you see it's more close to the linear distribution. If we go this way, it will get more and more close. Even if the precision will go haywire and at the really small numbers, because we can go even smaller than the actual segments of the Bezier of the polynomial. So let's just go and use 1000. So it's really precise. And so this is the copy to points. This is this node. And now I want the rail actually. So I start with a grid. Yeah, it's here. What a grid is, it's actually a grid node, but it's not really a grid because I have a grid of 1 and 1, so it's a quad basically. So with a small width and a bit higher height, then I rotate it and transform it near my rail. So it's here. You can see the quad there, and I can even go like this. And then I extrude it based on the projected curve. So it will be extruded over the already placed under rails, or how they are called. So now we have extruded geo and a somewhat colorized material. I just added. This is just a material group, so I just set the material to steel. It's not really looking like steel, but that's what I'm going for. And then I'm setting the material group because the final mesh will be basically two submeshes, and this material should be applied to this to the second submesh because it's indexed from 0. And then I'm merging these, and now you can see we have this kind of, if I had two, we would have like two, we would have standard rail, but I wanted a monorail, and you can see uh, the final distribution over the terrain. And I can even go and make it like more precise. So let's say that I want these segments, I want the higher. I can even go like uh, divisions. I can parameterize it using, I don't really have that parameter, but let's add it. It will be 200. Yeah, the divisions is not there. I still need to work with these errors to make it more user friendly. Okay. And now I have the divisions. It's automatically found. And if I go, I don't really need to go to the graph anymore. I can just change this to here. So I can go with 500 divisions or even more if I want it. So you can parameterize this, and I think it's like a bit too many. Let's go with 300, and I can obviously just go and change the curve, and everything will change accordingly. So it will get reprojected, and all this stuff will will just update accordingly. So this is not really workable, but it's doable in math. So you can have like these kind of rails. It's funny to play with this. It always is. So you can change it like as you want. This is not part of the mesh. It's a different mesh, so different submesh, and we are working on just the first submesh. I will need to add that functionality on the project. So the first submesh is actually the green one, which is what we want to work with anyway now. So it's not really that. Okay, I just moved the start, and it went wrong because the start of the curve needs to be where the this grid is, basically here. So I can move that, but then I need to move this as well. It's doable to have a null node with a transform, and then somehow at the moment it's not possible to bind the actual single point to a reference or to a variable and so on. So it would be tricky, but maybe I will think about that later. Okay, I want to keep this video under 20 minutes. So I just want to mention that, for example, one of the features that will be moved into Dash, I'm not sure that people will use it, but the Machina is very useful. That I can actually bind any data binding to and from string. So basically, this curve is a complex structure. It's a structure with different parameters, with points and so on. And I can bind all that from just a string of floats. So how it's done is a new attribute that this is editable as string, and then the inspector and some of the framework will just show it as a string and use these two specified methods. So as you can see, it's an onWrite and onRead. So it will basically onRead, it will read the points, which is I just need the points here. So just read from the points I have, which is a list of vector 3. And then once it's written, so once it's edited here, it will get written back to the points. So on. This is a useful feature. I can use this to bind from anything, but I have a couple of ideas in Dash where it will be usable. So that's it, guys, and I hope you found this video at least inspiring, and any feedback as usual is welcome. Thank you.